In this video, we'll look at the relative accessible surface area data function in ChemCharts. The relative accessible surface area, or RASA, data function will calculate the fraction of solvent-exposed surface area for each amino acid in a protein. This data function was originally developed for use with the suite of antibody data functions to help identify surface-exposed residues, which could be problematic, but it can be used with any protein. For this example, I'm using the output table from the antibody structure prediction data function with a PDB structures column and a gene bank column containing the concatenated antibody chain sequences. For any input sequence and structured pair, the protein sequences must be the same. This is true for these columns since they were both generated by the antibody structure prediction data function. In this case, the concatenated chains column also has antibody numbering annotations. The RASA data function will preserve these and other annotations when generating a new output column. From the data function settings dialog, select the table, the sequence column, and the structure column to use as inputs. The data function can be applied to all rows or a subset of rows in the table based on marking and filtering. Annotations will be created to indicate when a residue is considered solvent exposed. Enter a value for the % RASA above which a residue is classified as exposed. The default of 7.5% was taken from a paper by Revvity et al., which defined several metrics for antibody developability and can be calculated with the antibody developability data function. To change the color of the exposed residue annotation, click on the box to the left of exposed residue color and choose a color. Annotations can also be created for all residues using a color gradient related to the level of RASA. Choose a color for the starting and ending colors corresponding to 0% and 100% RASA. When the data function is finished, a new column is created in the data table. I'll switch to the Biomolecule viewer showing the predicted antibody structures and expand the table. The sequence and annotations from the original input column are present in the new column, and new annotations are shown. Since I chose to annotate every residue with its RASA value, a row of annotations is present, which is colored based on the starting and ending colors chosen in the data function settings dialog. In this case, orange represents maximally buried, and blue represents maximally exposed. Hovering over any annotation will provide details for that residue. This leucine, for example, has 0% RASA, while the glutamine next to it is 44.8% exposed. We'll come back to these residues in the Biomolecule viewer in a bit. Based on the input RASA cutoff, residues that are considered exposed are annotated with a blue circle. Hovering over the annotation provides a pop-up with information about that residue. The sequence pane in the Biomolecule viewer can be configured to show the new column with RASA annotations. Click on the viewer and select the new RASA sequence column. The sequence pane now shows the RASA annotations, and hovering over any annotation provides additional information in a pop-up. Clicking on any residue or its annotation will highlight that residue in the structure. Going back to the residues we looked at in the table, the leucine with 0% RASA is buried. The adjacent glutamine with 44.8% RASA is on the surface of the antibody. The Biomolecule viewer integrates the individual residue RASA values with the 3D structural information, allowing you to explore details of the structure in one visualization. Thank you for watching, and check out the other ChemCharts data function tutorials.